All right. 2-5. Yeah, are we optimistic that the next time I'll see you is Monday? Okay. I think it's gonna be bad tomorrow. Yeah, for sure tomorrow. Maybe we'll have to be here tomorrow. Is that what you're saying? Oh. I think it's gonna snow enough during the school day that they're gonna be cautionary. That would be my guess. Let's hope he's being cautionary. It's all about your safety, right? Okay. All right. So yesterday we did population variance and population standard deviation, and this was the formula we had for population variance, and this was the formula you wrote down yesterday for population standard deviation. Today we're just going to edit that slightly to turn it into sample variance and sample variation. So remember, population means you're calculating something for everybody in a group, and sample means it's a portion of your group. The only difference in this formula versus the one you have as far as calculation goes is the denominator is no longer an n, it's going to be an n minus 1. But everything else here means the same thing. They just use different variables when we talk about it. So instead of that little lowercase sigma, the circle that has the line sticking out from it, they use an S here for our sample variance and standard deviation. And instead of the mu, which is kind of like the, how to describe it, like a little squiggly line, for a mean, we use X bar for the mean. We saw that before with sample.
Are there actual definitions for them for those equations?
They're the same definition as population. The only difference is you're calculating it for a sample. So you can just put the formula in there if you want. Okay, and then just like yesterday, the standard deviation is going to be the square root of the variance. So we usually calculate variance first, take the square root of that, and we get our sample. Okay. So, you guys, Olivia, you have a question?
What is the population standard deviation formula?
It is, hold on guys, I'll flip back. Population standard deviation was this guy yesterday. So it's the same as the variance formula, we just took the square root on both sides. Okay, so the variables change. We have instead, when we talk about samples, an S, an X bar, and a lowercase n, and then the biggest difference is we divide by an n minus 1. So we change it to an n minus 1 when we're talking about a sample. We want, when we divide, to get a smaller, a larger number. That gives us a little more room for error. When we're calculating something for a sample, we don't have everyone's information. So we make our standard deviation a little bit bigger to account for that margin of error, the people that we're maybe not surveying or not included in our data. So that's why we have an extra -1 there. Okay, so what I want you guys to do on the handout from yesterday, flip it over. The next problem on there is very similar to the one that we did together. So you're going to order your data in the first column. You've got the raw data listed. Then you're going to find the deviation. So deviation was x minus the mean. You'll have to calculate the mean. Then you're going to take your deviation squared, and the bottom of that deviation squared formula, when you sum it up, that's your numerator here that you're looking for. And then you can use that number to calculate the standard deviation and the variance. So you can use the example on the other side from yesterday to kind of walk you through it. Biggest difference is just that n minus 1 in the bottom, and then way the variables will change a little bit, but they all mean the same thing. Okay, so you guys work together if you want on this, like 5, 6, 11 minutes, whatever you need to do that problem on the back of your worksheet. We're doing sample variance and sample standard deviation. You will probably need a calculator. Go ahead.
May I borrow a calculator?
Yes, you may. What is going on here? How you did here? There you go. If you want to check in this column your deviations before you start squaring and adding and things, remember this deviation column should always add up to 0.
Okay, square all the numbers, we get 39. Yep.
How close does your rounded number have to be? Like we
So-
got for our standard deviation, we got 1.803.
That's off by quite a bit. What'd you have for variance?
3.25. You divide it by 12.
Yeah.
Oh, so this is a sample, so you're dividing by n minus 1 instead of n.
Oh.
That's why.
Even
Even for standard deviation.
Oh, we did
Yeah.
that only for, okay.
So when you're gonna notice throughout the semester, when we do problems, wording is key. If it says population or all or every, it's one set of formulas potentially. And if it says sample, like this one, it's gonna end up being a different set of formulas. Okay,
So for the
similar.
samples for every equation, we're gonna do it divided by 11 instead.
Well, I mean, these different equations are different.
Well, we mean like,
But
yeah,
as
but
far
I mean
as-
like for that one.
As far as
yeah,
variance and
minus
standard deviation go, if it's a population, you divide by n. If it's a sample, you divide by n minus 1. And dividing by n minus 1 gives us a little more room for error because it's just a sample that we have. We don't have everyone's information. We don't have all. Okay? So that would be the only difference. Okay, now as far as rounding goes, 2 or 3 decimal places is a good number to stick with. You know, when you do your math Excel, they'll tell you what to round to.
Wouldn't be 39.
We just talked about that. So it's a sample, so you divide by n minus 1. Okay, so if it was a population, you divide by 12, because it's standard. You divide by 12. Okay, yeah.
I'm kind of confused on like how you like what you like plug into like the sample variance, sample standard deviation equations.
So our formulas are, I just want to look at this, like, it's less of something you're plugging in and more like instructions is how you want to read that. So when I see this big formula, okay, like that, okay, that's my variance formula. It's instructions. We're not actually plugging something in here as we go through. So you're going to kind of work your way from the inside out with order of operations. I'm going to take each of my x's and I'm going to subtract the mean. You have to do that for every single data value, which is what we did. We did that in that second column. Then we're going to take each of those, take it one step further and square it. That's what we're doing in the next column. Then we're going to add all those up, and that's where we get the 39. So this 39 is using that formula, but we're not plugging in, like what you do with like an algebra equation or so. Okay, so think of it like instructions. And divide by n minus 1. Okay. Any other questions on this? Okay. Standard deviation is not bad. Variance isn't bad. Just kind of tedious because you got to make the tables when you're doing it by hand. Now, I'm going to show you how you can check your answer with the graphing calculator. You guys want to take your calculators out if you don't have them out? So on tests, you will not be allowed to use your graphing calculator. But when we get to projects and of course homework, you want to be able to check your answer maybe before you put it in Math Excel so you don't lose an attempt. This is going to be helpful. So I want you to hit Stat. It's right next to our arrows. Hit Edit. And then you should see an L1 and an L2. Does everybody have an L1 and an L2 in their calculator? Yeah? Okay. So clear out whatever's in there in L1. That's the only one we need right now is L1. Okay. To clear out what's in it, you're going to go up to the list name, hit clear, and go back down. And then L1 should be empty. Good? All right, take this data and put it in L1 real quick that you guys have in your table for recovery time there. So 4, 5, 6. Move that over a little bit. There we go. Okay, and if you hover over the last 10, it'll say L1 and then parentheses 12. That means entry 12. So that's telling me I have 12 data values there. So that's a good way to like count them up. If you have a lot of numbers and you know there's supposed to be 12 of them there, you can double check that 12 things are there. Good? Okay, now once you've got the data in there, you're going to hit Stat, go over to where it says Calc, and then we're just going to select option number 1 variable statistics. So if you just have a single column of data, you're going to use this. It should already be set to use list L1. Does everybody have list L1 there? Okay, and then just hit enter until you have this output, just a bunch of stuff it's going to throw at you. Pretty much anything it can do with that list of numbers. So here are things it's telling us. We know X bar means mean, so it's calculating the average for us. It added up all of our X's for us. If we add up all the data values from the raw data, we get 90. Sum of X squared we don't need right now. That's something we use for later on. Now, the next two lines are important. These are both standard deviations. Your calculator doesn't know that the data that you're putting in represents population or sample. You know that. So you have to know, based on what data you put in, do I use the population value or do I use the sample value? Because one of these, the formula, they divide by n, and the other, they divide by n minus 1. It's the only thing your calculator knows how to do is to plug it in those things, right? So the one with the s is sample. The one with the lowercase sigma is going to be the population, and then you just choose whichever one's appropriate for the data you have. And then if you guys scroll down, you'll see it gives you some other things too, like n. It tells you there's 12 data values. It tells you min, max, median. It also gives a Q1 and a Q3 that we're going to use in the next section when we do the box and whisker class, upper quartile, lower quartile. We talked about those before. So it gives you a lot of good stuff all at once there. So use this, sparingly. You want to practice at least 1 or 2 standard deviations when you're doing your homework by hand if you can, just so you're used to the process. But if you want to check your answers with the calculator as you go on, you can do that. Just know that you won't have it. Good. Great. Okay. So, moving on. The next thing I need you to put somewhere is this. Now, you need to be able to put this whole chart in your notes somewhere. I don't know if you want to squeeze it in a little box. I don't know if you guys have room. Maybe on the back of the definition paper would be a good place to put this even. Here's Evans. There you go. Okay, so this is our empirical rule. Empirical rule is for what we call a normal curve or a bell-shaped curve. Have you guys seen this shape of a curve before? Potentially? Okay. So if our data makes this shape when we graph it, in whatever type of graph that we're looking at, we call it a bell-shaped or a normal curve. The mean is going to be right in the middle. The mean and the median actually will be right in the middle when we have a bell-shaped curve. And then the blue, the yellow, and the green little regions here represent data that is within 1 standard deviation, 2 standard deviations, and 3 standard deviations away from the mean. This tells us what's sometimes called the 68, 95, 99.7 rule. If I am within 1 standard deviation of the mean in either direction, so that blue area, 68% of the data is located in that area, okay? If I am within 2 standard deviations, I go out to include now the yellow regions, and 95% of the data is included within 2 standard deviations. If I go out 1 more standard deviation, so I'm 3 standard deviations away from the mean, we now have 99.7% of the data included. Okay, and then this doesn't add up to 100, right? 99.7 if you add up all those numbers, so there's an extra 0.15% that's past 3 standard deviations in either direction. So we like to say that for sure anything that is more than 3 standard deviations away is considered an outlier. It doesn't really fit with the rest of our data. So once we know now how to calculate a standard deviation, we can use that to figure out how much of our data is located where, and maybe the data value I have, is it an outlier? We can start analyzing that type of thing. Okay. All right, so make sure you have this picture and each of those percentages. 34 in the blue regions, 13.5 in the yellow regions, and 2.35 in the green regions. Okay, empirical rule or the 68, 95, 99.7 rule. Okay, so you can use this picture to figure out what percent of the data lies in certain places. In terms of the mean, because the mean is in the middle of our curve, there's always 50% above the mean and 50% below the mean. That's assumed, including that extra little 0.15 that we see on the edges, okay? Now, if I want to know what percent of the data is below this standard deviation between the yellow and the blue here, well, I can't really add up those two numbers because I've got this extra guy at the bottom here. So what we can do is say, well, from the mean to the left, I know 50% of the data lies there. And I know 34 is here. So if I have a data value that falls between the blue and the yellow region, I can say, well, that means if 34 is here, 16% of the data must lie below that value. And then you could look the other way. You could say, well, 50 plus 34, 84% of the data must lie above that value. So we start using things like that when we talk about like percentiles, like somebody's in the 16th percentile, it means 16% of people are below them, okay? When my son was born, he was in the 0 percentile. That's pretty small. Yeah?
What does that S represent?
That's a standard deviation. So this symbol means we've got our mean minus 1 standard deviation, our mean minus 2 standard deviations, our mean minus 3 standard deviations. On the other side, we've got standard deviations above our mean. Okay, everybody have what they need here? Got all our numbers? All right, so the next slide, you don't need to write this one down. We'll just kind of talk about it real quick together here. It says, use the empirical rule. It says, we're given some information about a data set. We don't actually have the data set. All we know is the mean speed of a sample of vehicles along a stretch of highway is 67 miles per hour, and a standard deviation is found to be 4 miles per hour. Estimate the percent of vehicles whose speeds are between 59 and 75 miles per hour. And this is just a generic curve with those lines drawn in. Now, if I know the mean is 67, that's the middle of my curve, right there, okay? I also know my standard deviation is 4. So every line we go out, we're just going to add or subtract 4. I'm going to add 4 as I go to the right and subtract 4 as I go to the left. So 71, 75, 79, 63, 59, 55. The question is asking what percent of the data lies between 59 and 75. Well, let me shade that. That would be all of that, okay? And you can see 59 and 75 are 2 standard deviations in either direction. So according to the empirical rule, if I'm within 2 standard deviations of the mean, what percent of data lies there?
95.
95 would be the answer. You could also, on the chart you drew, just add up those 4 percentages. Okay? Questions? Great. Moving on. All right. I have a handout for you that we're going to use. For standard deviation, we have grouped data. This guy. You will need your calculators for this problem. Yeah. There you go. Okay, so what we're about to do is the standard deviation formula that you guys were using a little bit ago. What makes this gross is there's 50 numbers here. So what we don't want to do is make a 50-row long table. That would take forever because we have to find all the deviations, deviation squared, and you can see from this data, a lot of the values are repeating. So what we're going to start by doing is just make a frequency table. We're going to take each data value that we have and count up how many times it occurs. X is our data value, F is our frequency. All right, so the data numbers that I have in this set, this is number of children per household, looks like. Starts with 0, and my biggest one is 6. So 0, 1, 2, 3, 4, 5, 6. Now we're going to count up how many times each of those occurs, cross them out as you go. So count up my zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 ones. Twos, 1, 2, 3, 4, 5, 6, 7. Threes, 1, 2, 3, 4, 5, 6, 7. Fours, I've got 1, 2, that's it. Fives, 1, and sixes, 4. Okay. And let's get a summation at the bottom of that column. It's going to be my N. How many data values we have total. We'll double check. I believe it's 50. 10, 19, 7, 7, 2, 1, 4. 50 at the end. Okay. All right. So we have a frequency table from the data. So that definitely condensed my information, but there's a couple adjustments we're going to make in our columns as we do the standard deviation, so we don't, again, have to make 50 rows. Next thing we're going to do is multiply all of our x's times our f's. So that would be 0, 19, 14, 21, 8, 5, and 24. If you remember, we did this yesterday when we did a grouped mean. We did x times f, and we added all of those up. We found that sum. That's the numerator when we calculate our mean. So add up that column. I get 91. Okay. Now it tells me at the beginning this is a sample, so we're going to keep that in mind as we go. I need to find a sample mean, so I would use an x bar to represent that. And that would just be the sum of all of my x's times their frequencies. We have that, 91. We did that yesterday. Divided by my n. Total number of data values, 50. 91 over 50 gives me a sample mean of 1.82. Okay, so now the next columns you'll recognize. X minus x bar means deviation. X minus x bar squared means deviation squared. And then we have one more column here. Each deviation squared is going to occur a certain number of times, f. So we're going to multiply by the frequency before we add it all up and get that number that's going to be in the numerator of our variance and standard deviation formulas. All right, so you need your calculator. X minus x bar, so 0 minus 1.82, negative 1.82. And then you can go ahead and square it as you go if you want to. If I square it, 3.3124. You could even take it one step further, multiply by the frequency, multiply by 10. I would get 33.124. So you can decide how you want to fill this out. You can do a column at a time, you can do a row at a time, doesn't matter. But again, we're thinking of these like instructions, okay? Step 1, subtract the mean. So 1 minus 1.82 gives me negative 0.82. Next step, square it. 0.6724. Next step, multiply by the frequency, 19. I get 12.7756. And then just keep going. 2 minus 1.82 is 0.18. Square it. 0.0324 times 7, like frequency, 0.2268. 3 minus 1.82 is 1.18. Squared, 1.3924 times the frequency, 7, to 9.7468. There we go. 4 minus 1.82 is 2.18. Square it, 4.7524 times the frequency, 2, 9.5048. 5 minus 1.82 is 3.18. Squared, 10.1124, and this guy has a frequency of 1, so it's just 10.1124 again. Last one, 6 minus 1.82 is 4.18. Square it. 17.4724 times the frequency 4 gives me 69.8896. Okay. That last column, our deviation squared times the frequency, represent every one of those data values. If we did the deviation, if we square it, and then multiplying by the frequency multiplies how many times it actually happens. Add that up now. Sum 33.124 plus 12.7756 plus 0.2268, 9.7468, 9.5048, thank you, 10.1124, 69.8896. I get 145.38. All of that work for that single number is what we're looking for. That number is the numerator of your variance and your standard deviation formulas. So my answers now. Come on, there it goes. Variance. What was that? A pass? Oh, she didn't give me one. She just said to send you down. Go ahead. For my variance, I'm just going to take that 145.38. Remember, this is a sample, so we are dividing by n minus 1. My n was my total number of data values, 50, so we are dividing by 49. 2.996, let's see, 967 if I give it 3 decimal places. That works. My standard deviation is just the square root of that variance. And in your calculator, you can just do square root of the previous answer. 1.722. Yes.
What made you decide in the chart that 4 decimal places would be the answer for you?
I only used 4 here because I didn't have to round if I used 4. That was an exact answer. If you have to round, like if it goes any further than that where it's just too much to write, you could say 3 if you wanted to. It won't make your answer at the end off by very much. Okay. Questions there? Okay. Flip your paper over. We're not going to do this whole chart, but I want to show you what the difference is in this versus the one we just did. The one we just did, the data values were singular data values, 0, 1, 2, 3, 4, 5, 6. Here they're full classes. You'll notice all these columns look the same as what we just did, but we don't have singular x values. So we talked about this a few sections ago. If you have a class and you need to use a single x value for that class, we use a midpoint, okay? So like the middle, if you want to find the average of 0 and 99, you'd add them up, you divide by 2, you would get 49.5, and that's the x value you would use for that class. Now, if you guys continue in that manner, you're going to see there's a pattern. The class width in this problem is 100, so those midpoints are going to increase by 100. Now, look at this last class. The last class, they didn't say 500 to 600. They said 500 plus, which means it's like this open-ended class at the end. So truly, you could choose whatever number you wanted here. You could make it 1,000 if you wanted to. I'm going to say if we don't have kind of an end to it, the most logical thing to do would just be to follow the pattern that you're seeing in the midpoints, whatever that is. So based on what we have there already, I would say 549.5. But that's one of those things in statistics that's kind of like open to interpretation. So that's not just the only way you could do that problem. But if you see classes like that and you have to find standard deviation, the setup is going to look like this. After that, then it's the same as the one we just did. I'll save you all the filling out the columns. Okay. The last problem at the bottom of your paper, you need to know this last formula. Just put it on that paper. We're not done yet. We got 6 minutes. All right. Put this on your paper right above the height weight problem that you see there. Coefficient of variation. So coefficient of variation is a quick little calculation with standard deviation and mean, and it's the same formula here again twice. This is the notation that you would see if it's a population. This is the notation you would see if it's a sample, but it's the same calculation either way. It's standard deviation divided by mean And then we really just turn it into a percentage is what that times 100% means. Now what this is used for is if we have two data sets that are not alike, like the problem we're about to do is we're going to compare height to weight. Those are dissimilar sets. So we calculate the coefficient of variation, and whichever one has a larger percentage has larger variation in the data set. So it just tells us this one varies more than the other one does. It's a way of comparing two things that aren't alike. Okay. Now, in order to use this formula, you need, the mean's not too bad, but you need standard deviation. And standard deviation involves all those columns. So this is an example of where our calculator is going to make our life easier. So what I want you to do in your calculator is that data table that you see there. I want you to put the height in L1, and I want you to put the weights in L2. Heights in L1, weights in L2. Yeah.
Does it matter if it's in order for putting in L1?
It does not matter if it's in order or not. No. Stat edit. And then remember to clear out the list. You're going to go up to the list name, hit clear, go back down.
Hello.
Hello.
I'm gonna need a minute. Sorry, you can just put it on my desk. Okay. All right, and at the very end, make sure you've got the same number of data values in L1 and L2. Okay. All right, so we're gonna do the same steps as last time. Once you're in there, you're gonna hit Stat, go over to Calc, but this time we're using two variable statistics because we have two columns. So just number 2. And then hit Enter a bunch until it gives you that output. Now here's what you're looking for. For each of these heights and weights, you need your standard deviation divided by your mean. Now for weights, they're going to use a y instead of an x. Okay, so can you find on that output s sub x, because that was our first column. What's the standard deviation of the x values? 3.44. Okay, and what's the x bar? Okay, if I divide those, 3.44 divided by 72.5, turn it into a percentage, 4.73%. That's the coefficient of variation for the heights. S sub y, what's that number? Go ahead, John.
18.47.
And what's the y bar? You have to scroll down probably to see it. Oh, I got 180. Oh, you have to scroll up a little bit. 187.83.
Yeah.
Divide them again. And I get, when I turn it into a percentage, 9.83%. The one that has the larger variation is the weights. And that's your answer. Okay? Cell phone lotto. Winner is 3. Who's number 3? Who said me? You get a ticket? Okay. 2-4 guys. Rain, shine, snow, sleet. Whatever weather events occur, your 2-4 Math Excel is due on Friday. Okay? 2-3 is due tonight, 2-4 due on Friday. All right, sorry about that. I wasn't expecting it for a few more minutes. Okay, that's good though. All right. Hey.
2 for 1.
I know, right? I got dinner for tonight. I got lunch for today. Thank you, sir.
Mrs. Reed told me there's a bunch of
That's okay. you want me to, send it, give it to you back to Amy? Okay. Done. 25, right? There you go. Thank you. You too. Oh, got all my deliveries too. We're good. All right. Maybe I'll see you Friday. Maybe I'll see you Monday. Maybe I'll see you tomorrow. Let's not say that. Let's not go. All right. You too. See you later. Bye. Have a good day.
Oh, this is only good for the test.
Bye. It's good for this current test, yes. But then you'll earn more tickets for the next test.
What about the yellow one?
The yellow one?
Yeah.
Oh wait, did I give you a pink one?
Yeah.
I should have given you a yellow one, Ryan. Those are for Trig. I've got the same ticket, they're just different colors with different chapters, so my bad. I would have.
Oh.
Yes.
I have a question about my calculator.
Okay.
So, I can show you, but on my list section, there's no like L1. I don't know why. Like, I don't.
Oh yeah, we can.
It says L2.
Okay, at some point you just hit delete and set clear.
Oh, did I?
Alright, so
Thank
hit
you.
that. Bye, see that? And then hit number 5. And then enter. Do that. Reset it. We're good.
Okay.
So when you go up, hit clear and back down. Back to the